In this video, I will demonstrate how to make wind simulations similar to computer fluid dynamics, also known as CFD, through TyFlow on 3ds Max. A quick disclaimer, the TyFlow operation that I'm about to do cannot be used to replace actual CFD as it is simply for visualization purposes, and it does not use calculations and real-life information to produce the data. It is otherwise useful for design-related school projects. Go to the link in the description to find out how to install TyFlow first before proceeding this video. And with that, let's begin. Firstly, try to bring up a scene to use. Make sure that there is a solid colored ground and buildings. The buildings will be key to creating interactions with the wind particles. In standard primitives, find TyFlow. Click and drag in the viewport to resize the circular icon. This icon is where the editor menu will be in under the modifier. Open the editor and a window will pop up. The TyFlow editor has a range of operators to use, which will be useful in creating animated particle movement. Feel free to check the TyFlow website for further documentation of the plugin. Link will be in the description. The first thing that we'll be placing is the buff operator. We want the objects to pale, and that is what the buff operators, which are in green, are for. Next, drag out the position icon operator. Next, drag out the position icon operator and click on create a new icon. Check the viewport and you should see it as a square shape icon. Orientate the icon so that it is facing up and with its arrows facing towards the buildings. Use the W key to move and the E key to rotate. Resize the icon that it is one long side that stretches to the building's furthest extent. Next, drag in the speed operator. The speed of the outgoing particles is going to be like the speed of wind. The magnitude in the speed operator will be how fast the wind will be moving by meters, or it can be read as meters per second or per frame. Most wind speeds are calculated as kilometers per hour, but you can easily convert to meters per second through googling the conversion. Change the magnitude to 7 and remove the variation. The set of wind particles that I'm creating will all emerge with the same wind speed. For the direction, change to long icon arrow. You can create any direction for the particles to flow. In this case, the arrow is pointing away from northwest and will be the direction to use. Scroll down and pick Ty icon as the object to activate the speed operator. Scroll down and remove noise. The noise map can affect the distribution of the speed in the particles, so convert it to all black. Now we will create the wind particles as moving splines. Drag out the spline operator and choose to create new. Press the play button at the bottom right of 3ds Max to see how the animation plays out. When the animation is played, the splines will start shooting out of the TyFlow icon in the direction of the arrow. We will adjust the settings of the spline so that it will become mesh. Ensure that the spline object is selected. Go to Ty Splines in the modifier. Change the thickness of the spline and increase the number of sides to make it more circular. Have the interpolation be adaptive for a smoother spline. Increase the distance threshold. This controls the minimum step size between points on a particle's trajectory in order for them to form a spline segment. Next, increase the maximum distance between two sibling particles in order for them to be conjoined with a spline segment. Reduce the maximum age to 200. Then, we will adjust the TySpline measure. Hit the icon next to it and it should turn into an eyeball. Now, you should be able to see the mesh surrounding the spline. Reduce the radius from 0.5 meter to 0.3 meters. Scroll down to adjust the taper so that the mesh looks less like a moving tube. Turn on the curve adjustment and shift the back point to be lower than the front point. The tube mesh will now have a sharp tapered end. Go and increase the number of sides to smoothen the tube. Play the animation and it should look like wind moving lines moving in the viewport. The wind simulation is now running through the buildings, but it is not how we want the wind to function. We need to create a collision operator with the environment. Open the TyFlow editor and drag in the collision operator. Select the buildings as the object to be collided with. Add in a small amount to the absolute radius. This is the collision radius of each particle. Wind does not touch buildings in reality, but for the wind splines to collide smoothly in 3ds Max, a small collision radius should be given. Scroll down to particle interaction and change the geometry surface interaction. Wind does not have high bounce and high friction, so these will be removed, as well as motion inheritance. Add a collision offset so that the wind particles will move a distance away from the buildings. When the animation is played, you can see some splines curving in while others pass the buildings because they are above the building height. In this case, we'll add a limiter to control the amount of space where the splines can move around. Drag in the limiter. We'll only limit the Z positions or the height. We still want the wind particles to move freely left and right. Change the lower Z to 0, which is ground level, and the height to 6 meters, which is the average height of the buildings in the scene. Turn off effect velocity. Play the animation and you can see how the wind splines are now kept within building height. Next, we'll add the slow operator. Once wind hits the building, it should slow down. Reduce the X and Y velocity to 50% and leave Z untouched. Scroll down to find objects and tick slow by surface proximity. We want the wind particles to slow down when they are in close contact with the buildings. Untick slow if inside volume and add in the buildings. Reduce the proximity influence to 2 meters since the absolute radius put was 1.5 meters. So we only want to affect the particles closest to the building surface. We'll now see the difference in wind speed between the colliding winds and the winds passing between the spaces. The last step is to set a target for the wind to move towards. The wind splines start from a single direction, but after collision or flowing normally, their routes become random. Create a plane that is similar to the TyFlow icon size. Resize it so that it is a bit taller but much longer than the building extent. Rotate it to be parallel to the icon. open the TyFlow editor. Drag in the Find Target operator in yellow and place it below collision. The wind won't slow down completely after collision, and it should continue to pick up speed. To do that, change the control by velocity setting. Set the velocity to be the same as the starting velocity of 7 meters. Increase the percentage of acceleration by 50%. Increase the distance effect for the target to be as far as possible because we want the wind particles to keep on traveling towards the target, which is at a rather far distance. Scroll down and pick the plane as the target for the wind particles to find. Now, the difference of the speed in the non-colliding winds are faster, but the colliding winds are also now picking up speed instead of fully slowing down. Zooming in closer, you can now see the slight bounce from the wind splines off the building. In the next video, more wind types will be shown.